1. In this video, we're going to explore topic 8.6a, error between curves more than two intersections. Alright, example number 1. The curves that intersect at more than 2 points. Find the error of the regions between the graphs. LS equals 3s cubed minus s squared minus 10s. And g of s equals negative s squared plus 2s. Alright, so we're going to graph this one. This one actually cubic function. So which is the blue one right here, f of s. And g of s is the quadratic function, the red one right here, g of s. Alright, now you need to find the intersection between these two graphs, right? So basically, you just let f of s equals g of s, which is 3s cubed minus s squared minus 10s equals negative s squared plus 2s to find the intersection points, right? And then both sides have the same negative s squared, you're going to cancel out, right? So you have 3s cubed, subtract 2s both sides, so it will be negative 12s equals 0. Factor 3s out, so you have 3s times s squared minus 4 equals 0. Then you have 3s equals 0 and s squared minus 4 equals 0, right? This guy turns out to be s equals 0 and s equals plus and minus 2, right? So you have three intersections right here. The first one right here, s equals negative 2, right? The second one right here, s equals 0, and the third one right here, s equals 2, right? So you're going to split these regions into two regions, right? The first one is A1 right here. The second one is A2, right? So the error equals A1 plus A2, right? Now A1, which is the integral from negative 2 to 0, right? Of the blue one subtract the red one, right? The upper one subtract the lower one, because this one is the integral with respect to s, keep that in mind. So it's going to be f of s subtract g of s, it's going to be 3s cubed minus s squared minus 10s, right? Subtract negative s squared plus 2s ds, right? Now, plus a2. a2 is the integral from 0 to 2, which is this guy right here. The upper one is g of s, which is negative s squared plus 2s. Subtract f of s, it's going to be 3s cubed minus s squared minus 10s, right? ds. Now, you're going to distribute the negative side, so this guy turns out to be integral from negative 2 to 0, right? Negative right here becomes positive, right? So you have positive s squared, and you have negative s squared right here, is to be cancelled out, right? Now negative times 2s is to be negative 2s, and you have negative 10s right here, is to be negative 12s, right? You will write 3s cubed ds. Now you simplify the second one at the integral from 0 to 2. Negative 3s cubed, right? Negative and negative right here becomes positive, and this guy right here cancel out, right? Now negative and negative right here becomes positive, so positive 10s and 2s could be positive 12s ds, right? Alright, now I'm going to take antiderivative of this one. It's going to be 3 over 4s power 4, right? Minus 12s squared over 2 is going to be 6s squared. Evaluated from negative 2 to 0, right? Now take antiderivative of this one, it's going to be negative 3 over 4s to the 4, right? Plus 6s squared, evaluated from 0 to 2, right? Now you're going to substitute 0 for s, it's going to be 0, right? Subtract, parenthesis, 3 over 4, negative 2, power 4, it's going to be 16, right? times sitting, subtract set times -2 square, right? Plus -3/4 times sitting, right? Substitute 2 over here, it's going to be plus 24. Sitting divided by 4 is going to be 4 times 3 is going to be 12, right? So it's going to be -12 right here. And this one right here, -2 squared could be 4, right? 4 times it could be 24. So you have negative side right here. It's going to be -24. So you multiply by -1 right here, it's going to be plus 24, right? Similarly, this one turns out to be -12 and then plus 24, right? And if you simplify this one, it's going to be 24. This one is the final answer. You can use the calculator to check your work, right? Now let's move on to example number 2. The figure below shows the graph of y equals 2 minus 1/2 s squared and the line y equals 1. For s from -2 to 2. Set up the intervals for the sum of the errors of the shaded regions, right? So very simple, right? You have 3 shaded regions right here. The first one is here, right? The second one is this guy. And the third one is this guy, right? So the question just asks you to set up, so basically you just set up, you don't need to calculate, right? So the error becomes, now you need to find the intersection right here first, right? You know that the first intersection is here, right? So you're gonna let this guy right here equals this guy, right? To solve for s, right? So you have 2 minus 1/2 s squared equals 1, right? Multiply both sides by 2 right here. So then you have 4 minus s squared equals 2, right? So I have s squared equals 2. S equals plus and minus √2, right? So this one right here actually -√2, right? And this one right here actually √2, right? And this one right here is -2, this one is 2, right? So the error becomes the interval from -2 to -√2 of, look at this one right here, the upper one subtract lower one, the upper one is y equals 1, right? This is y equals 1. The lower one is the function right here, right? So you have 1 minus parenthesis 2 minus 1/2 s squared ds, right? Be careful. You must have the parenthesis of this one, right? Plus the integral form -√2 to √2, right? Of the upper one subtract the lower one, right? Upper one is 2 minus 1/2 s squared. Subtract lower one, which is 1, right? So right here you don't need to put parentheses, right? Because you only subtract 1, right? Right here you subtract a polynomial, right? And you put the s right here. And the last one plus the integral form √2 to 2 right here, right? Of the upper one is y equals 1. Subtract lower 1, put parentheses right here. 2 minus 1/2 s squared ds, right? And this guy is the final answer. Now let's move on to example number 3. Let R be the regions bounded by the graph y equals e to the 3s minus s squared, the horizontal line y equals 1, and the y equals 3, as shown in the figure below. Find the area of these bounded regions, alright? So y equals 3 right here, and this one y equals 1, and this one is y equals e raised to the 3s minus s squared, right? This graph right here has 4 intersections. The first one is right here. The second one is right here. The third one is here, and the last one is here. Alright, so you need to separate them. Alright, you need to find the intersection right here. You know that intersection right here and right here already 3 and 0, right? Anyway, you need to calculate it, right? So I need to find the intersection right here and right here, right here. So does that mean I need to solve a system of equations, this guy and this guy right here, right? So I put this guy right here on the calculator, and I need to find the intersection because this one is the calculator active, right? Or if you want to solve this one by hand, that's fine, totally fine, right? Because you have e raised to the 3s minus s squared equals 1, which is e raised to the power of 0, right? So then you just equate this guy right here and this guy right here. So I have 3s minus s squared equals 0. Factor s out, so I have s times 3 minus s equals 0. So I have s equals 0 and s equals 3, which is right here and right here, right? Now, for the second one right here, I need to solve a system of equation, this guy right here and this guy right here. I need to use a calculator because I have the decimal number right here, right? So I'm going to print up the calculator, right? I'm going to grab this guy and this guy on the calculator and I'm going to find the intersection, right? So I need to go to home screen, hit on right here, grab right here, right? F1 of S is going to be e raised to the 3s minus s squared, right? Hit enter, it's gonna be right here. Alright, the second one is y equals 3, so I need to hit tab, so I put 3, hit enter, it's gonna be right here. Now I need to find the intersection right here, so I need to hit menu, analyze graph, intersection, go to the left, go to the right, it's gonna be 0.427, right? 0.427. Now the second one is hit menu, analyze graph, intersection, go to the left, go to the right. It's going to be 2.57. So you have three bounded regions. The first one is right here. This one and this one should be the same. The middle one is right here, actually the rectangle, right? So you have error is, now I call this one A1, I call this one A2, I call this guy is A3, right? So does that mean A1 and A3 they're both the same, right? So can I combine them as 2A1, right? Plus A2. Now 2A1, which means the integral from 0 right here to 0.427, right? Upper one subtract the lower one. The upper one is the function right here, right? Because it's going to be right here. The lower one is y equals 1, right? So you have e raised to the 3s minus s squared minus 1 ds, right? Plus the middle one right here from 0.427 to 2.57. The upper one is y equals 3. The lower one is y equals 1. So 3 subtract 1 is going to be 2 ds, right? Now I'm going to put this guy on the calculator. I need to hit home screen right here, hit calculate. Now I need to hit menu, calculus, integral, right? I need to put 2 in the front right here, right? Integral from 0 to 0.427 of e raised to the 3s minus s squared minus 1, right? ds plus menu calculus integral from 0.427 to 2.57 of 2 ds. Hit enter. The answer is 5.03391, right? So this one equals 5.03391. Now let's move on to example number 4. Find the area of the regions bounded by the curve y equals sine s, cosine s, s equals 0, s equals pi over 2, right? Now you need to grab this guy and this guy, right? So I have s and y coordinates right here. Now observe that the sine and the cosine function have the same period. It could be 2 pi, right? And then you need to find the length of 1/4, right? So you're going to take this one divided by 4. So I have 2 pi divided by 4 is going to be pi over 2, right? So from here to here I have the period is 2 pi. Divide 2 pi in half is going to be pi. Divide this one in half is going to be pi over 2. Divide this one in half is going to be 3 pi over 4, right? So you have 4 quarters. Each quarter has the length of pi over 2, right? Now, this one is the maximum is going to be 1, minimum is -1, right? You know that the sine function starts from the origin, right? And it's going to be right here, right? Go up to the maximum on the first quarter. The second quarter go down to the midline. The third quarter is the minimum. It's going to be right here, right? And the last quarter is going to be right here. So it's going to be something like this. Alright, now the cosine function starts from the maximum, so it could be right here. Go down to the midline. Go down to the minimum right here. Back up to the midline. Go up to the maximum. Alright, so it could be something like this. Now x equals 0 is going to be the y-axis, right? So it could be right here. Now x was pi over 2 is going to be right here, right? So you have two regions. The first one is right here, and the second one is right here. So which is right here? You see that A1 and A2 right here. Alright. And you need to find the intersection right here, right? In order to find the intersection, you need to let sine s equals cosine s, right? This guy right here equal this one, right? Because they both equals y, right? So divide both sides by cosine, so it could be sine s divided by cosine s equals 1, right? Assume that cosine always not equal to 0, right? Because if cosine equals 0, it's going to be undefined, right? So it could be tangent s equals 1, right? So you have s equals pi over 4 plus n pi, right? Where n is an integer, right? Now if n equals 0, you get pi over 4, right? So which is right here, pi over 4, right? Now the error becomes the integral from 0 to pi over 4. The upper one subtract lower one. The upper one is the cosine function. The lower one is the sine function, right? Look, the orange one is above the blue one, right? So you have cosine s subtract sine s. Now plus the integral from pi over 4 right here to pi over 2, right? Look at the intersection right here. Now the upper one is the blue one, which is sine s subtract cosine s ds, right? Now you're going to simplify this one by taking the antiderivative of this one, right? So antiderivative of cosine is going to be sine s. Antiderivative of sine is going to be negative cosine, and you have negative side here, it becomes positive cosine, right? Evaluated from 0 to pi over 4 plus the antiderivative of sine s is going to be negative cosine s. Antiderivative of cosine s is going to be sine s, right? So it's going to be negative sine s right here. Evaluated from pi over 4 to pi over 2, right? Now substitute pi over 4 for s, so sine pi over 4 equals root 2 over 2. Cosine pi over 4 is going to be root 2 over 2. Now substitute 0 for s, it's going to be sine of 0 is going to be 0, cosine of 0 is going to be 1, right? Now this one right here plus negative cosine pi over 2 equals 0, right? Sine pi over 2 equals 1, right? Minus 1. Subtract pi over 4. Cosine pi over 4 equals root 2 over 2, so it could be negative root 2 over 2. Sine pi over 4 equals root 2 over 2, so it could be negative root 2 over 2, right? Root 2 over 2 plus root 2 over 2, it could be root 2, right? This one is negative 1. This one is negative 1, so it could be minus 2, right? Now, this should be negative 1, it could be plus root 2, right? So it could be 2 root 2 minus 2. This one is the final answer. Now, there is a faster way to do this one. Observe that this region right here and this region right here is symmetric about s equals pi over 4, right? Look. Alright, and they're both the same, right? So basically, you just calculate the error of one region right here and you multiply by 2, right? So basically, I just put 2 right here and I don't need this one. So it saves my time, right? You still get the same answer, right? The answer for this one right here is root 2 minus 1. Then you're going to multiply by 2, you get this one right here. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.